Hello everyone. Hope you're all doing good. So today we are here for grade 9 maths. The chapter name today we discuss that is probability. And here are the list of the lesson which is identify the independent and dependent events, theoretical probability, experimental probability, compound events, find the number of outcomes, probability of independent and dependent events. You can find all the lessons on aplusstudent.com. You have to log in by using their email and password that is provided by the administrator. Select Maths from the subject tab. Scroll down to the grade 9. Click it, and here are the list of the chapters related to the grade 9. So we are on statistics. Sorry, not statistics, it's probability. I just forgot it's probability, okay? And today we start a very first chapter which is identify the independent and dependent events. So first of all let me guys tell you like what is the meaning of dependent and independent events. So as we know that an independent event is an event which the outcome is not affected by another event, okay, and the dependent event is affected by the outcomes of a second event. Like when we are going to example, for example, like when we are choosing a card, okay, from a deck, and then choosing another without putting the first card back in the deck, okay. So this is a basically example of, you can say that a dependent or independent, or the one more example, like for example, how long you sleep, okay. This is an independent variable and affect your test score, which is the dependent. This makes sense, but your test score affects how long you sleep, okay. So this is the difference between the dependent and independent events. So now, so Steve calls a bakery and orders a custom cake with a certain design. Later the day, Bryce calls to order a custom cake. Are these two events dependent or independent? Two events are independent if the outcomes of the first event does not affect the outcomes of the second event. Okay? So the two events are independent because the Steve choice of design does not affect the Bryce choice. So this is independent, because as we know that the meaning of dependent and independent is an independent event is an event in which the outcome is not affected by another, but the dependent event is affected by the outcome of the second event, okay. So this is affected by the outcomes of the second. So Greed is making a beaded necklace and plans to use each bad color once. Great selects a red bead and then reach for another color. Got it? Like look at here. They are saying that like Garrett is making a beaded necklace and plans to use the each bead color once. And Garrett selects a red bead and then reach for another color. First he select the red bead and then reach out to another. It means that it depends. So are these two events dependent or independent? Yes, it's dependent events because like look, grade does not wants repeat. The selection of the first color limits the selection of the second color. Got it? This is a basically, you can say that, a dependent event. Okay? So now let's just discuss the next one, which is Leora pulls a coin out of her pocket and places it on the table. Okay? Then she reaches back into her pocket and takes out a second coin. Laura pulls a coin out of her pocket and places it on another table. This is a basically, and then she reaches back into her pocket and takes out a second coin. Are these two events dependent or independent? Look, first of all, he pulls a coin. Just let me. First of all, he pulls a coin out of the pocket and places it on the table. Then she reaches back into her pocket and take out a second coin. So it depends, like which coin she just basically pick for the second choice. So it means that these two events are also dependent because Laura does not put the first coin back. So her first pick affects which coins are left for her second pick. So this is the dependent event. Okay. So this is the meaning of dependent and independent. So here we are going to finding it out, the dependent and independent. All right, hope you guys understand this one. So if you want to check this question, so we are going to check this question as well. So look at here. Kenny picks a marble at random, put it back, and then put another marble at random. Okay. So then she pick another marble at random. So are these two events dependent or independent? So let's just check, are these two events dependent or independent? Okay. So as we know that two events are independent because this is the random marble. So we are not know like which marble she put first or which marble she does not affect. Okay. So we can say that this is a basically independent event. All right. Hope you guys understand it. Let's check for one time and then. So here is for the next. Harry spins the spinner twice. Look at here. This is the spinner. Are these two events dependent or independent? It's a twice. So it's independent. It does not depend on any of it. Okay. Hope you guys understand this lesson. Let's do the theoretical probability. You spin the spinner once. Okay. You are going to use the spinner once. So what is the prime, which is a p? Write your answer as a percentage because theoretical probability now we are going to finding. Okay. So what we are going to finding it out? The theoretical probability. All right. So here, let me just open this one. So here is your spinner. Okay. So what is the prime? And write your answer as a percentage. P is showing the prime number. Look at here, the prime. As we know that first one is like 3 by 4. How we can say that? Because 3, how many total section? These are 4. and how many number, which is 2, 3, 4, and 5. So how many total section? These are 4. And how many the prime numbers in it? It's 5 is a prime, 2 is prime, 3 is prime. So it means that 1, 2, 3. So 3 is prime over the total, 3 by 4. So let's divide 3 over 4 and then just multiplying with the 100, then you are going to write your answer. Like for example, if I'm going to say that here is a spinner, okay, and look at here this one, and like it's 2, 3, 4, and 5. All right, and they are saying that using for the prime, finding the p. How many total section? It's 1, 2, 3, and 4. So total is putting here. How many prime numbers? 1, 2, and 3. Or you can say that, for example, here is like it's not 5, here is 6. So how many prime? It's only 2 prime number. So what's your answer? 2 by 4, it's 1 by 2. Okay, and when you're going to just divide it and then you're finding it out. So it's 1 by 2, and when you divide 1 over the 2, so what's your answer? Which is zero point 0.5. So p is equals to zero point 0.5, and then you are going to multiply with the 100. So for percentage, I'm going to multiply with the 100. So this is a 50%. Understand? This is the way to solve that question. All right, let's do another. So you pick a marble at random. Now you guys pick the marble randomly. So how many total marbles? And they are saying that what is p? And they are saying that probability for yellow. We are going to find the probability for yellow. Okay. First check it out the total. First check it out for the total, and then we are going to check for the yellow. So how many total marble? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 are total. How many yellow are there? So it's 1, 2, 3, 4, 5, 6. So 6 by 12. Okay, understand? So this is the probability. Total we are going to put in the denominator always. In the denominator we are just going to put it out the total number, total outcomes, total number, and how many you are interested you're going to put on the top. This is the basically the probability. Okay, this is the same. So let's do this one. You pick a marble at random. What is probability for orange? So first of all, how many total, and divided the how many you interested. Okay, so we are interested in only the orange, and how many orange are there? There is only one orange. And how many total are there? Let's count. 1, 2, 3, 4, 5, 6, 7. 7 is total and 1 is orange, so 1 by 7. Okay, you pick a marble at random. So we are going to pick the marble. So how many we are interested? What is the probability of purple? So write your answer as a percentage. So first we check it out. How many total balls are there? Okay, the total balls is basically 4. And how many purple? There are 2 purples, so it's 2 by 4. So this is 1 by 2, again zero point 0.5, and this is 50%. Okay, let's do some test questions for that. You spin the spinner once, finding it out the probability of prime or factor of 70. Okay, simplify your answer and write it as a fraction or whole number. So look at here, prime, or you can say that a factor of 70. 4 is a prime number? No, it's not a prime. Is 4 a factor of 70? No, it's not. Okay, let's check for 6. 6 is a prime number? No, it's not. Is it a factor of 70? No, it's not. Let's check for the 5. 5 is a prime number, or you can say that as well as it's a factor of 70. Okay, so how many total? These are three columns, sorry, three basically the total you can say that it's divided into three equal parts. And how many you interested? Only for one. So let's check the answer. This is 1 by 3. Sorry, 1 by 5. Sorry, 1 by 3. 3 is total and only 1 is a prime. Okay, got it? This is the right. Let's do it. You pick a card at random. What is the P probability of blue? Select your answer and write it as a fraction or whole number. So first of all, count it how many total cards are there. It's 11. How many you interested? Only for blue? How many blue? It's one, 2, 3, 4, 5, and 6. 6 over 11. Option B, okay? Okay, this is the right answer. So now, what is the probability of tail? And write your answer as a percentage. So you just solve this question by yourself and also solve the rest of the test questions by yourself now. Okay? Hope you guys understand this lesson. Now let's discuss the next lesson. So experimental probability. So first of all, let me tell you what is like experimental probability. So as we know that what is the meaning of experimental probability? For example, if you're going to finding it out the probability of something like the difference between the experimental and theoretical. Okay, so we can say that if they are saying that like just finding it out the experimental probability, this can be found by repeating an experiment. Okay, and you are going to observe the outcomes. So what is the probability? This, for example, like if I'm going to say that a coin is tossed 10 times. Okay, a coin that is tossed 10 times. A head is recorded 7 times and a tail is recorded 3 times. Got it? How much the head recorded and how much the tail recorded. So you are going to write it down. P of head, probability of head, like for 7 times out of 10, and probability of tail, that is a 3 time over the 10. So this is the probability, like number of times or number of events that is occur or over divided by the total number of trials. Number of times, or you can say that the events occur or total number of trials. Okay, Now let's discuss the questions. Hope you guys understand the definition. Yeah, let's open. At Ice Cream Heaven, 16 of the last 20 sandy salt had nuts. So, what is the experimental probability that the next Sunday salt will have nuts? Okay, so how much? It's 16 of the last 20. How much the nuts? These are 16s, and how much total? This is 20. So 16 over 20. So just simplify it and we're getting the answer. So this is the probability of the nuts. How much of it? 16, and how total? These are 20. Okay. Sasha is watching a baseball game. So far, 2 out of 4 batters have gotten a hit. So what is the experimental probability that the next batter will get a hit? So how much probability for the hits over the total? So how many hits? These are 2. And how many total batters are 4? So 2 by 4. And when you are going to more simplify, this becomes 1 by 2. Okay, look at here a question. In that question they are saying that you guys just answer me. Okay. A miniature golf course recently provided its customer with 16 golf balls, of which 8 were orange. So, what is the experimental probability that the next customer will receive an orange golf ball? Okay, you guys think about it and then just answer me, everyone in the chat. Think about it and then just tell me the answer. What's the answer for this one? I'm going to open this here. So, as how much of it they can say that orange over total. So, how much the orange? Out of 8 were orange. And how much total? That is 16. 8 were orange and total is 16. So, 8 times 1 is 8. 8 times 2 is 16. So, it's 1 by 2. Understand? Okay. So, this is the probability of orange. So, in this one, there were 10 dogs at the dog park last Saturday, and 5 of them were Yorkshire Terriers. What is the experimental probability that the first dog to arrive at the park next Saturday will be Yorkshire Terriers? So, check it out. How many? 5 of them. And how many total? The total are 10. So, 5 divided by 10. Just simply, when I just used to suppose, this is the way to solve. You guys, everyone, tell me how to solve it. No one? So 5 out of 10. So this is the same. 1 by 2. Okay. Alright, just check it out. The next question. Let's move it. Restaurants often slip takeout menus under Jamal's apartment door. So far, Jamal has collected 20 menus. How much? 20, including 10 for Japanese food. So, what's the experimental probability that the next menu slipped under Jamal's door will be from a Japanese restaurant? Simplify your answer and write it as a fraction or a whole number. Probability for the Japanese. Japanese over total. So how many Japanese? 10. And how many total? These are 20. 10 over 20. So 10 times 1 is 10. 10 times 2 is 20. So 1 over 2. Okay? It's the same. So relay runs a stable that bore 20 horses and 4 of them are bay. What is the experimental probability that the next horse that comes to board will be the bay? So choose horses and total. Just simply how many of it? 4 of them. Okay. And how many the total? These are 20. So you are going to divide 4 over 20. When you are going to divide it, then you get the same answer. It's just a simply division. Okay, you are going to divide the two numbers like 4 by 5 sometime, 4 by 20, 10 by 100, 6 by 30, like this way. Okay, so hope you guys understand this lesson as well. So solve the rest of the questions by yourself. Okay, so the fourth today we discuss, which is compound events, find the number of outcomes. So you pick a card and spin the spinner. So how many outcomes are possible? So these are the three cards, which is 3, 4, and 5. 3, 4, 5. Yeah. And for the spinner, these are 7, 4, 5, 6, 7. Okay. Look at this, a tree diagram. For 3, it's 4, 5, 6, 7. For 4, it's 4, 5, 6, 7. For 5, it's 4. First of all, 3 with the 4, 3 with the 5, 3 with the 6, and 3 with the 7. Like I'm going to draw it here, then you guys understand it. Okay. So here, when uh when we are going to draw it, like it's this way. So how many of it they are given? These are given 3, 4, and 5. Okay, these are the events which is given. So first it for the 3. As we know that for the 3, first of all, it's for like, so it's for 4, 5, 6, and 7. So for the 4, first of all, it's 3, 4, then it's 3, 5, then it's 3, 6, then it's 3, 7. 3 for every number. Okay, we put it 3 with all the numbers. Now when we're going to move for the 4, so let's do for the 4, that one is 1, 2, 3, and 4. So for the first one it's okay. For the first one, like here put it 4, 5, 6, and 7. Same thing for 4, it's 4, 4, 4, 5, 4, 6, and 4, 7. Okay, now for the 5, it's again the same 4, 5, 6, and 7. It's 5 and 4, 5 and 5, 5 and 6, 5 and 7. Look at here all these now. I'm just going to small it. So for the tree diagram for 3 there are 4 outcomes which is given, that is 4, 5, 6, and 7. So we are going to move first of all 3 with the 4, 3 with the 5, 3 with the 6, 3 with the 7. For the first attempt, for the second this is the same thing, for the third this is the same thing. This is the basically the tree diagram. Okay, so how many total branches? Total these are 12. Okay, so the number of possible outcomes are 12. That's it. You guys understand it or not? This is a very easy, okay? You pick a marble and pick a card. So how many outcomes are possible? So first of all, let's just check. Is like they are saying that 2, how many of it marble cards? They are saying that just for the simplification we are going to move R is representing red and W is representing for white. Look at here how many balls. There are two balls which is one is red and one is white. For red we are going to put 1, 2, 3, 4, 5, 6, 7, 8. So red with 1, red with 2, red with 3, red with 4, red with 5, red with 6, and red with 7, red with 8. All of it. Same the thing for the white. All of it. Count it how many total branches. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So the total it's are 16. Okay. Okay, now you guys tell me this one. You spin the spinner and roll a die, so how many outcomes are possible? So now I'm going to tell you. So how to make a tree diagram? Look at here. How many things are given? Only when you see the dice, it's like 1, 2, and 3. Then it's with the 4 and with the 5. Okay? And same thing, one you're going to put 1, 2, 3, 4, 5, 6, and then again one is for 1, one is with 2, one is with 3, one is with 4, one is with 5, and one is with 6. Understood? And the second as well and the third as well, all of it. Same questions, we already done it. Same questions, we already done it. Yeah, this one. Now you guys tell me this one. No one? Here is the spinner and pick a card. How many customer are possible? Spinner and these are the cards. So for the spinner that is NQOP. So for N RSTUVWX all cards, then for P all cards, then for O all the cards. Okay? So you guys check. Okay? Like this way. Hope you guys understand this lesson as well. Now let's discuss the last lesson of the day. Okay? Probability of independent and dependent events. You pick a marble at random. Without putting the first marble back, you pick a second marble at random. Find the probability for yellow to yellow. Okay, just both finding both the probabilities, but these are zero. First, finding the first probability of yellow, then probability of yellow, then multiply with each of it. So look at here. Now find the probability of first of all, you have picked a yellow marble. How many yellow marble are there? Two. How many total? Five. It's two by five. And in the second, after you have picked a yellow marble, the following marbles will remain. There are four marbles remaining. Of those marble, one is yellow. Got it? And for the second, we are going to put this one. How many total? Four. And how many yellow marble? It's one. So 2 by 5 times 1 by 4. It's just a simply multiplication. Now you're going to multiply the numbers. Okay? 2 by 5 and 1 by 4. This is the same thing. Multiply numerators with each other and multiply denominators with each other. So 2 times 1 is 2 and 5 times 4 is 20. 2 over 20 and getting solve it. 2 times 1 is 2, 2 times 5 is 10. It's 1 by 10. That is the probability. Okay? That is the number of possible outcomes. Alright, check the second question. So, this is again the same thing. You pick a card at random. So, these are the different cards. You're going to pick it out a random. Okay? And then they are saying that without putting the first card back, you pick a second card at random. So, we are going to finding it out the first of all the probability of blue. How many total? It's 5. And how many blue with it? It's only 1. So, probability of blue is 1 by 5. Now the blue is just basically like out from there. Now for the second is orange. How many orange are there? Now two orange and how many total? It's 4, 2 by 4. So 1 by 5 times 4, then multiplying and then we're getting the answer. Hope you guys understand this lesson as well. So today we have covered the grade 9 maths. The chapter name, this is a probability. These are the names of them, okay? So when if you still need any help in any of the question, then you can contact the tutors. There is a chat button on your A plus app. So select the department there and then just putting their, for example, the maths help and then just putting their name and then chat. Okay, this is the new method we introduce it by using so you can contact easily the tutors. Hope you guys understand the lesson as well. And if you still need any help, so you are using this method to contacting the tutors. So for now, have a good day.